All right, this is your homework help video for Tuesday. We are going to put numbers in the correct category. Okay. Now, on in the previous video, we talked about the different categories that numbers could fall into. Remember, every number is a real number. And then real numbers are broken into two groups. You have rational numbers, numbers that can be written as a fraction. You have irrational numbers, numbers that can't. These are the three types of numbers that cannot be written as a fraction. Those decimals that have the dots at the end, they're non-terminating decimals. They continue on forever, but they don't have a pattern as to how they repeat, like 1 5 1 5 1 5 1 5. If it has a pattern, then it's rational because you know what number is coming next. If it doesn't have a pattern and it keeps going on forever, then it's irrational. Okay, it's unpredictable. Pi, you know the symbol pi that you use and formulas that are circles. Okay, that number that represents pi is also a non-terminating decimal. So pi is irrational. You can't just put a 1 under this number and call it a fraction, okay? You can't do that. And the last type of number is going to be your non-perfect roots. Those are going to be your roots in which the answer is going to be a decimal. So anytime the answer is a decimal, when you're simplifying these roots, it is going to be irrational. You cannot write it as a fraction. Okay? All right, all right, all right, all right. So now let's put these numbers in the correct in the correct grouping. Remember, any and every number is going to be a real number. So that means that all of these numbers are going to go under real numbers. So that's going to be 4/5 is a real number. -18 is a real number. 0 is a real number. The square root of 5 is a real number. Negative fraction, real number. A negative decimal is a real number. A whole number or an integer of 5, real number. Pi is a real number. The repeated decimal is a real number. And then this decimal that has the dots at the end, we got 1, 8, 2, 3, 1, 5, 9, dot, 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 be continue. That is also a real number. Okay, so now I'm gonna work backwards. Which of these numbers you cannot write as a fraction? Which of these numbers is going to be rational and which is going to be irrational? Remember, rational can be written as a fraction. Irrational cannot. This is a fraction. Okay, this is a fraction. So it is rational because it's a fraction. And I'm going to move this so you don't think it's a negative. This is rational. Okay, a negative number is rational. You can write -18 as a fraction. 0 is rational. Okay, you can write it as a fraction. The square root of 5. If you type this in your calculator, you're going to get a decimal answer. It is irrational. Okay? A -1/2. Negative fractions are rational. It's already a fraction. Okay? It's rational. Negative decimal is rational. Okay? It stops right here. It's a terminating decimal. It stops. It's rational. You can write this as a fraction. The whole number 5 is rational. You can write it as a fraction. Pi, look, pi is over here as an irrational number. You can't just stick a 1 under it and write it as a fraction. It's a long decimal that repeats without a pattern. So it's irrational. We're going to put this here as irrational. Okay? Dot, dot, dot. Oh, sorry, y'all. I'm writing the wrong number down. My apologies, okay? That's rational. This is the pi. It's irrational. Okay. I had a brain fart. This repeated decimal, you know what number is coming next. It's going to keep going. You got 2.53513, 513, 513. All of these numbers are repeating over and over again. 513, 513. So guess what? Since you know what number is coming next, you can actually write this as a decimal. As a fraction. So it's rational. These are the three numbers that are repeating. This next number with the dots at the end, it's repeating and it doesn't have a pattern as to how it's repeating. This is going to be irrational. It's a non-terminating decimal. Okay? Integers are whole numbers. Whole numbers do not have fractions attached to it. They do not have decimals attached to it. And they're opposite. So integers are going to be negative numbers, positive numbers, and zero. All right, so let's look at it. This fraction it's not a whole. It's not, that means it's not an integer. Look, negative 18 is a negative whole number. It's a negative number. It's an integer. It's negative. 0 is an integer. The square root, it's irrational, so that's no way that it could also be, if numbers are irrational, that's all it can be, is real and irrational. Cannot be anything else. It does not, none of these numbers will fall into these other groups, okay? So mark that out. We got a fraction again. Can't be an integer if it's a fraction. A decimal again. Can't be an integer if it's a decimal. You have 5. That's an integer. Pi. It's irrational. Can't be an integer. You have a repeated decimal. It's a decimal. It can't be an integer. Integers are only whole numbers and they're opposite. Positive numbers, negative numbers, and 0. That's what you're looking for. So neither one of these fall in that category. These are your only integers in that group. Whole numbers. Whole numbers start at 0 and they don't have fractions attached to them. They don't have decimals attached to them. And it goes on to the positive infinity. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 100, 101, 102, 103, 104, 105. They do not have fractions or decimals attached, okay? So your whole numbers in this group is going to be, it's not this. This is not a whole number because it's negative. This is a whole number, 0. And your other whole number is going to be 5. Those are the only two whole numbers in the group. Okay? So now I want you to do the chart by yourself. I want you to put an X on which one of these numbers is going to be a whole number. This is whole number, it's hard to see. Which of them is going to be an integer? Put a check in the box if the number is an integer. This is rational. I'm going to abbreviate and put rat. Irrational, and real number. Okay? All right. So you're looking at -7. We know -7 is a real number, so we're going to put an X in this box. Okay? That's a real number. This is hard to see. So let me put another number there for you. Let's do the square root of 49 here. Okay? Square root of 49. All right. So you're going to put every single number is going to be a real number. So you need to make sure you put X's in all of these, because all of these numbers, every number you can think of is going to be a real number. Here, I'm going to put, let's see here. Let's put a whole number here. Let's put 25, okay? Or let's put 22, because this is hard to see. So I'm just going to put these numbers for this space, this number for this one, okay? So now you're going to check off. Is -7 a whole number? Put a check here. Is -7 an integer? Put a check here. Is -7 a rational number? Put a check here. Is -7 irrational? Put a check here. Okay? We're going to do square root of 2. Is it a whole number? Is it an integer? Is it a rational number? Is it an irrational number? 22. You're going to do the same process. Put X's in the box, or you can put a check, whichever one is better for you. You can, because it says just make, it says make a check mark. Read the directions, Miss Reyes. It says check marks. But if you put X's, that's fine. I'm okay with that. All right. So you're going to put a check or X in the box that where these numbers are a part of that group. All right, y'all. Have a good one. Have a good one. I'm slide up a little bit. Have a good one, okay? All right. If you need help, let me know. Bye.